Have you ever wondered why we actually have those patterns on our fingers? Most people would say so the police can catch criminals or so your phone doesn't slip out of your hand. But that's wrong. In this video, we'll reveal the real secret of our hands. You'll learn why fingerprints aren't just patterns, but a highly advanced natural amplifier that works like a microphone. We'll explain why koalas have fingerprints almost identical to humans, how Alan Turing's mathematics draws patterns on our skin before we're even born, and why without these ridges, you would be touch blind. The collapse of the grip theory. For a long time, scientists believed that fingerprint ridges worked like tire treads, improving grip. Sounds logical, right? But in 2009, biologist Roland Ennis conducted an experiment that destroyed this idea. It turned out that ridges actually reduce the contact area between your finger and an object. And according to physics, less contact area means less friction. In other words, if our fingers were perfectly smooth, we'd actually hold a cup more firmly. A paradox emerges. Nature gave us a pattern that seems to make grip worse. So why? The secret of sticky fingers. In reality, fingerprints do help us hold objects, just not in the way we expected. They work as a moisture control system. The ridges block pores, trapping microscopic droplets of sweat inside the grooves. This keeps the skin soft and slightly moist, flexible. That perfect moisture balance creates a stickiness effect that works on both dry and wet surfaces. Nature didn't design tires. It designed a smart hydration system for optimal grip. Fingers that can hear. The real breakthrough came when French physicist Jean-Louis Debrasius asked, what if fingerprints are sensors? He knew that deep beneath our skin lie special nerve endings called Pacinian corpuscles. These receptors are obsessed with vibrations. They respond best to a frequency of about 200 hertz. Debrasius calculated that when you slide your finger across a surface at a normal speed, the ridges strike tiny surface bumps and generate vibrations. And do you know the frequency? Exactly 200 hertz. This isn't coincidence, it's precise tuning. The artificial finger experiment. To prove this, scientists built a robot. They created two artificial fingers, one smooth, one patterned like a human fingerprint. Both sensors were dragged across different surfaces. The result was astonishing. The fingerprint finger captured powerful vibration signals at the exact needed frequency, while the smooth finger detected almost nothing. Debrasius proved that the skin pattern changes the nature of the signal itself. It's a built-in biological filter that removes noise and amplifies what matters. A 100-fold amplifier. How does it work? Imagine your fingers as seismographs. The ridges concentrate mechanical pressure into specific points instead of spreading it across the skin. Because of this, vibrations from touching fabric or wood are amplified up to 100 times before reaching the nerves. Without fingerprints, you'd feel textures 100 times worse. Pacinian corpuscles sit just 2 millimeters beneath the skin, and the ridges act like a hearing aid, allowing you to sense surface details 1,000 times thinner than a human hair. A matter of life and death. But why would ancient humans need such extreme sensitivity? The answer is simple. Survival. Millions of years ago, there were no supermarkets or expiration dates. We had to feel whether a fruit was ripe or already rotten. A ripe banana vibrates differently under your fingers than an unripe one. That difference in vibration could save your life. We evolved these super sensors to separate good food from bad before it ever reached our mouths. The mathematics of zebras and leopards. Where do these unique patterns come from? Geneticists discovered that they follow the mathematical rules described by Alan Turing. The same equations that create zebra stripes and leopard spots also draw the lines on our fingers. The process begins around the 10th week of pregnancy. 3 genes compete, determining the height and spacing of the ridges. The fascinating part is that genes define only the general structure. The fine details depend on randomness, how the fetus moves, how a finger presses against the womb. That's why even clones would have different fingerprints. Greetings from koalas. We're not alone in the universe with such hands. Koalas also have fingerprints, and they're so similar to human ones that even forensic experts can confuse them. Our evolutionary paths diverged about 100 million years ago. This is called convergent evolution. Nature independently invented the same solution twice for the same problem. Koalas also need to select the freshest, juiciest eucalyptus leaves, so they evolved the same high-precision sensors we did. Technology of the future. Today, engineers copy the structure of our fingers to build better robots. Robots with smooth sensors used to be clumsy. Now, by adding artificial fingerprints, engineers teach them to feel textures with micron-level precision. So take a look at your hands. Those lines aren't just for unlocking your phone. They're one of the oldest biological interfaces on Earth, turning touch into a signal your nervous system can hear. You carry an engineering marvel that lets you see the world with your fingertips.